The City Intelligence Lab is an incubator that fosters intelligent design solutions for more sustainable cities.
The City Intelligence Lab is a place to conduct research that goes beyond just academia.
The CIL is, for me, is really a place to experiment with technology, with theories related to urban planning, and also how to integrate this into practical workflows. I think this is really a strength we have here.
At the City Intelligence Lab, we focus on intelligence. How can we extract, articulate design intelligence, and put it to practice?
It aims to infuse state-of-the-art technologies such as artificial intelligence, augmented reality, or computational design into the planning of our cities by making it more accessible to designers and planners. The CIL is both a physical as well as an intellectual space. The lab itself is located here in Vienna, and it is part of the Digital Resilient Cities unit of the Austrian Institute of Technology. And it is designed as an immersive space with interactive walls and tables that enables an augmented design experience. But the lab's intellectual space extends far beyond these walls into an international team of people that work across the globe to develop cutting-edge research and methods on urban performance, and a set of online platforms and tools that make these methods accessible to everyone. We can say that the CIL is aiming to develop both the back-end and the front-end of intelligent urban planning. On the back-end, a powerhouse of artificial intelligence-driven simulation and performance analysis allows real-time performance feedback and informed design decisions.
AI has given us a whole swath of new tools at not only the designer's disposal, but anyone in the design process.
These modules let us perform urban design tasks in ways that we could have never imagined before.
And on the front end, interactive online and augmented interfaces allow designers, city planners, and other stakeholders to collaborate intuitively and in their natural environment.
In the lab, we experiment a lot with different technologies to make exactly this happen, and you can interact with the digital models almost if they would be physical. And on top of that, you can see what effect your interaction has on microclimate, on traffic, on walkability of a quarter. And finally, this makes it so much easier to communicate designs, decisions, and also trade-offs associated to designs to experts and, even more importantly, to non-experts and citizens.
One of our main research efforts here at the CIL is Infrared, our intelligent framework for resilient design.
Infrared is a performance-driven design and planning platform that allows us to get a very holistic view on the city as a complex system.
Infrared is a set of interfaces and performance models that allow users to understand in real time the impact of their design. It is built with state-of-the-art machine learning models and large simulation datasets that we've developed in-house.
It's more so about democratizing artificial intelligence. It's a way to allow non-experts use these tools.
We're currently developing Infrared by applying it on pilot projects, and that allows us to understand the actual challenges of integrating performance feedback on existing design workflows.
It is precisely through that interaction between the human designer and these tools that design intelligence is produced, and that we can start to build a new kind of intuition.
Infrared allows us to design cities with performance in mind. Every time you change anything in the design, shift a street, a metro station, all performance layers are updated in almost real time, thanks to our AI-driven models.
This almost instantaneous viewing of results allows anyone to really do what experts do.
And this example here shows a large-scale city extension project. We coupled our platform with parametric urban massing models. And here you see it in action. First of all, we experiment with variation of street networks and the distribution of building density. For each variation, our algorithms predict wind comfort, solar radiation in just a few seconds. With the street network and population distribution, we can make assumptions on the attractiveness of different areas for retail and amenities. And that is an important factor for the walkability of a whole, which in turn influences the mobility choice of people, and therefore also traffic, noise, and air pollution. So in this sense, we also try to anticipate and plan together with market mechanisms to mitigate common issues associated with top-down planning. Now, in the next step, we started to find ideal locations for public facilities, parks, schools, and those kind of things, and with a goal to maximize equal access to them for all citizens. And again, this is an interactive process. It's live and data-driven design in action. Here we sketch out the route of a bus line in our area and fine-tune the locations of the stations in order to maximize passenger potential and access to the transit system for our citizens.
A big advantage of the intelligent framework for resilient design, InfraRed, is that it can also be integrated with generative models and optimization algorithms. And this way, we would have a more holistic optimization of an urban system. For instance, in a study case, we integrated into one framework the spatial configurations, graph-based analysis such as mobility and accessibility, with deep learning accelerated predictions of microclimate metrics such as wind and solar radiation. And based off the visions that we aim to achieve and the respective indicators, we concluded on actual and tangible fitness objectives. This way, we came to an optimal urban form according to the objectives. Its strong point, it's the rapid feedback, of course, which allows us to engage in collaborative, manual and iterative design processes as well. And this becomes directly a data-driven collaborative design process.
There's been so much great work done training the microclimate prediction models here at the CIL. But if you're not someone who spends your weekends trawling through Git repos, you might find it hard to utilize this work. Setting up the environment locally, ensuring library versions, and generally getting to a point where you can make your own inferences can at times prove to be a real barrier. And so one of the things CIL has placed an emphasis on is the deployment of InfraRed. Enter infrared.city, a web application that gives anyone in the world access to infrared simply through their browser. Currently, we have deployed 2 of our machine learning models, wind comfort and solar radiation, with more to come in the very near future. Now on the website, you can play with these models and get almost instantaneous results from any location. We've added the ability to input context-specific data, such as the wind speed and direction for wind comfort snapshots. And we're currently working on adding a swath of different outputs and metrics that can provide real meaning to these predictions. No longer is the complex analysis done by experts hidden behind this barrier. Anyone, anywhere, who has access to their browser can see the impact of microclimate analysis on their own neighborhoods.
In a nutshell, what we're trying to do here is make the most advanced performance-driven urban design methods accessible to all designers by distilling design intelligence through our tools.